Hello and welcome. Today we're going to be talking about both distance and midpoints. This will be section 1.3 in our book, and we're going to ask ourselves, how do I determine the midpoint as well as finding distance between 2 points? So our first thing again is going to be highlighting our examples. So we're going to highlight example 1 in blue, and the very easy thing that you learned when you were very, very young is finding the distance between A and B on a number line, which there are multiple ways you can do it. The first one is just counting 1, 2, 3, 4, 5, 6. There are 6 jumps. So this distance D is equal to 6. Now, that's not always practical. So what we can do is we can say the distance is always the absolute value, because we always have to have positive. So distance is always positive. So that is something we highlight, as we know, in yellow, because that's a piece of key information. So we have these absolute value symbols. Those are vertical lines. And we're going to take our first number of -9 here, and we're going to subtract it to figure out how far it is away from -3. So we're going to take -9, and we're going to subtract this from a -3, and then make it positive. That's what these symbols say. So in this case, we figure out what is the inside of this. So -9 minus a negative, which turns into adding 3. So -9 plus 3 gives us a -6. So this turns into -6, which those absolute value symbols actually turn it to be +6. So again, these symbols say turn it positive, which is why it's always positive. Now, we could have went the other direction. So we said it could have said -3 minus a -9. So we can do that as well. So our second way is distance is equal to -3, and then again minus a -9, which gives us 6 as well. So what we're going to do is talk about another thing called a middle point. So that's a quick introduction of distance. We'll talk about larger distances. So what about the midpoint of something? So midpoints is a new definition to some, maybe not all. This is going to be the middle of a line segment, because we'll be talking about geometry. It kind of is like in the middle. So if I just draw a random line segment, and I have A and B here, if I wanted the middle, you don't want to go like here or here. We kind of want to go exactly in the middle, so it's equal on both sides. So midpoint assumes that this side is congruent to this side, which is what those tick marks mean again. And we can say that this length is, let's say, 4, and this length is 4. This would be your midpoint. And let's put M here. So we'll put M is our midpoint for this problem. Now, things to note that you should want to know is that AM, segment AM, is congruent to segment MB in this case. So again, that is also a key piece of information. So let's go ahead and talk about finding the midpoint on a number line. So let's go ahead down here. Let's go to examples 2 and 3. Again, let's highlight those correctly. Example 2 in blue, example 3 in blue, because they're examples. Now finding the midpoint, not too bad. Like, we could just literally say, well, that's in the middle, so that's my midpoint. So -8 is your midpoint, which is not that hard to do. So, but I want the idea of finding it using some math skills. So we could just literally say this side has 1, 2, 3 jumps. This has 1, 2, 3 jumps. So that's the middle, which is -8. Or what we can do is we can kind of average the numbers. So our midpoint will always kind of be the average of them. So what we're going to do is averaging things. An arithmetic average is adding the numbers. So we're going to take this number of -11 and -5, and we're going to add those together. and then we divide by 2. There's only two numbers, so we divide it by 2. So if we simplify that, negative 11 and negative 5 is in fact negative 16, and we're still dividing that by 2. And then 16 divided by 2 is 8. The negative tags along and gives us negative 8 for both of those midpoints. So that would be finding the midpoint there. Again, you could just use the number line and find the exact middle, or we can think about the average. The average is important because we'll be doing that as we move forward. So let's get into example 3, which will be using segment addition as well as midpoints in some cases. In this case, this is not using a midpoint because it does not say, but it does say this figure below, B is between A and C. So B is in the middle of it somewhere here, or in between, not in the middle. It would say the midpoint, so that'd be exactly the middle. And then we know C is between B and D, so C is in here. And we know that AD is 12, so let's write down all of this information. So AD is right here, is that full length. Let's go ahead and do that in blue like we did the other time. So A to D, all the way from here, all the way to here, is in fact 12. We know that BC, which is right here, let's do that in red here. BC is 3. And we know that B to D from here all the way to here is actually 10. So this whole length from here all the way to here is in fact 10. Now we are going to find A to C. So what is, let's see, what color did I not use? Let's do orange here. So we need to find this length right here. So that is kind of my question mark. Now, the key thing to note is that we could figure this out with segment addition. If we find little a and little b, this length here, we could actually add this to find this whole length here. By the way, there are multiple ways we can do that. So in this case, let's highlight, let's see, what did I not use? We used all of those. We can kind of use yellow here. Let's just say that's yellow. I think you can see that. But the idea is, if we think about this length, this yellow length, and this green length, the whole length, the green length plus the yellow length actually equal this whole blue length. So if we put like an X here, we can just say that X, and then we're going to do plus that 10, and it will equal 12. So again, this length here and plus the rest of it is all equal to 12. So X plus 10, which is 12. Or in this case, that X ends up being equal to just 2. 2 plus 12 is, or 2 plus 10 is 12. So now to find this, if we know this is 2 and this is 3, well, this entire length here is just 2 plus 3. That is one way we can do it. So we can just do 2 plus 3 is equal to that AC, which AC then is in fact just 5. That is what we're looking for. And that would be labeled as units because we want to make sure we have some sort of unit. So let's go ahead and start example 4 here, which we will write that highlighted in blue. Again, let's highlight example 5 in blue, and then we are going to use a distance formula, which is a formula or kind of definition kind of thing. So we'll do that in green. So let's go back here and look at the problem. So segment addition and midpoints. Again, this time we will have a midpoint. So in the figure below, S is between Q and T. So S is somewhere between Q and T. And R is going to be the midpoint of QS. So R is in the middle. So what we can do in our piece of paper is write that that is in fact congruent to that. Now let's write some stuff in there. Well, RS is 2, so if this is 2, well, that has to be 2 as well. So this is showing your work. If you were doing a test or anything, you'd want to draw the midpoint. Those are congruent to each other. That's step 1. That'll be like a point. You write RS is 2. That's another point, and copy it over here. So that'd be like 2 total points together there. Now we know that R to T is going to be 10, so from here all the way here is in fact 10, and we need to find Q to T. So we have to find this distance right here. So, and this is very, very nice because we know right here to here is in fact equal to 2. Well, if we put 2 and 10 together, that is that whole blue length. So we are going to do 2 plus this 10, which is equal to this question mark, or that blue length, which I'm going to erase that question mark and write that as QT. The way to write that is the length of segment QT is just like that. So we're going to write this as QT here. So in this case, we just add the two together, which is in fact 12 is equal to QT, and that would be 12 units for that final answer. So let's go ahead and get into our very last thing, which is the distance formula and the midpoint formula. So we're going to talk about the distance between points and the midpoint. So we're going to talk about the distance formula and the midpoint formula here. Well, the distance formula is something you should have learned. We're going to find 2 points, any 2 points, and find the distance between those 2 points with this formula. We're going to label these points x1 and y1, x2 and y2. The 1 represents point 1. The 2 represents our second point. It doesn't matter which order you pick the points, as long as you establish one as point 1 and the other one as point 2. So how do I do this? Well, I'm going to start with x2, and I'm going to subtract x1. And then I'm going to do y2 minus y1, and then I'm going to figure that out. I'm going to square it to make it positive. That's what it does. And then we will add them together, and then we square root it to undo the squaring, essentially. That is the formula. So in this case, how do I do that? Again, we start labeling. This is x1, this is y1. That's my first point, so the x and y value of those. This is x2 and y2. Again, I could flip-flop those, so this would be x2, y2, x1, y1, as long as it's 1 for both and 2 for both. So in this case, we have G and E. How long or how far are those apart? Well, that distance is equal to the square root of, well, we're going to plug those in and square it and then add them together. So in this case, we're going to take x2, which is -1. We'll subtract -5. Again, you're taking x2 minus x1, which negative turns into addition. Then we'll do y2 minus y1. It has to always go in that order. So we have 3 minus -1 here for that other y, which if we simplify that out, this turns into a +4, and we square it, which is 16. Also +4, and we square it, which is 16. So 16 plus 16 is in fact 32. Now we type this into a calculator and figure out approximately how many units it would be, which, rounding to the nearest hundredth, is 2 decimal places. We get 5.66 units for my answer. So let's try the midpoint and find one more example of that, and then we'll be done. So in this case, we're going to still use x1, y1, x2, y2. In this case, we're going to take an average x1 plus x2. So what are the average of the x's and the average of the y's, which is kind of like we did on the other side. So we're going to average the x value, the change in x and the change in y, and then we're going to use that. So again, labeling the points, so x1, y1, x2, y2. We're going to just add them together, the x's. So our midpoint is going to be equal to a point. So we're going to have a parenthesis set and another parenthesis set with a comma in between. And let's go ahead and put a fraction symbol. So let's go ahead and add our x values. So if I do x1 plus x2, again, I'm taking the x values and dividing that by 2. Now I take the y values, which is -3 plus a -7, divide that by 2. Figure out what is this on top. If you're typing this all in one go on your calculator like this, you'd have to put parenthesis sets around those and then divide by 2. In this case, we have 5 plus a -7, which is -2, divided by 2, which gives me a -1. And again, it's a parenthesis set. And then when we do the other one, we have to close a parenthesis. So -3 plus -7 is -10, divided by 2 gives me -5. Again, our answer is a point. It's a midpoint, so we need all of this. If you forget something, you will lose points.